Hello again, this is Todd Frazee with the video tutorial for the S60-133 CAD model of the washer for the Stirling engine series. Again, you're going to go into Canvas and you're going to download your drawing and print it if you don't already have a hard copy of it. And the revision may vary from what you see in this display. So you want to build your part to the correct revision. Alright, so we're going to go and let's take a look at our washer part in the main view. What would be in the front view is you're looking straight in at the circular shapes. Our material is brass, half hard to ASTM 816. This is a little tiny washer. You can see in the 1:1 scale it's pretty tiny. And we're going to use a third technique to make this particular part. There's actually a fourth, but we're not going to get into revolving in this series until the next lesson. So we're going to do an extrusion. We'll do an extruded puck, and then we're going to use what's called the hole wizard to make the hole. Okay, so let's go to SolidWorks. We're creating a new part. Select OK. Again, first thing we're going to do is we're going to save. And we're going to save it as the 133. And we're going to double check our drawing and make sure the revision matches, which is 0. If yours is not 0, you need to put the correct R number for the revision. And again, there's your name. And we're going to save this. Okay, I'm going to make planes visible. And we're going to do our sketch in the front plane because that's how it's represented on the drawing. Okay, we're going to select sketch. We're going to select the front plane. The view is going to snap to the front plane. We're going to select the circle tool, circle, and we're going to hover over origin, which is where the planes come together. And you should get a coincident icon. And we're going to drag off to the left. We're going to hit escape or press the green check mark to exit that mode, and we're going to try to drag our center point around, and if it moves, you're not attached to origin. Now we're going to go back to our drawing and we're going to see what diameter this is. So the diameter is 0.24. So back to SolidWorks. We're going to pick the Smart Dimension tool, pick on the circle, click out in space, and it's 0.24. Okay, the size gets real small, but hopefully your screen auto updates. And we're done with that sketch. We're going to exit the sketch, and if you had it fully constrained, there should not be a negative symbol inside captions here on the left. Okay, now we're going to go to Features, and we're going to do an Extruded Base. Okay, it'll pop to a 3D view, and if you had the sketch already highlighted, it's going to assume it. Otherwise, it's going to ask you, do you want to make a new sketch or select one? Okay, so here's where we get thickness. So we need to go back to our drawing, and the thickness is 0.039. So let's go back to SolidWorks, and we're going to call that 0.039. And we get the thickness of our washer. Hit accept, and you should have an extrusion that looks like so. Okay, we're going to use the hole wizard command to put our hole in the center, and again we're doing a hole that's somewhere in between the two sizes here. Now if we use the hole wizard, we're restricted to pretty much making holes that are designed around drill bits. So we are not going to hit the exact median of the tolerance on this, but we would be selecting a drill bit that's in the center of that tolerance. That's as close as we can get. So we're going to go to back to SolidWorks, and we're going to use the hole wizard, and we're going to do a plain hole. or pick ANSI inch. And the hole wizard, the advantage of it is any of these styles of holes, you can come back and change the hole feature or pattern of holes to match the style. So you could add countersinks very quickly by just changing the type to a counter bore or counter sunk hole. Or you could add threaded features or turn it into a slot. Okay, so we're going to do ANSI inch. And you have different options. You can do different systems. DIN is German, Great Britain. There's ISO, and there's ANSI metric. So most things in the United States are going to be ANSI inch or ANSI metric. And it allows you to pick the standard drill sizes, or you can pick specific series of drills. So it breaks out just the letters or fractional sizes, or pipe taps or screw clearance. So in this case, the hole is a screw clearance hole, but we're going to use all drill sizes, and we're going to select a drill bit that is close in diameter to what our drawing is. Now, I don't have the drill charts memorized. It's set up to help you select the drill type you're using. So we're going to initially, before we start doing anything, we're going to pick this show decimal value. So it'll show you the decimal equivalent. And we're looking for the decimal equivalent of something that falls halfway between 0.064 and 0.069. So ideally it would probably be 0.06, 0.5. We may not be able to find that exactly to the 10th using drill bits because there aren't that many sizes available. So we're going to scroll down till we see 0.06, something close. Okay, so we got our options are 0.0635 or 0.067. So I think 0.067 is as close to 0.066 or 65 as we're going to 665 is we're going to get. So we're going to pick the number 51 drill. And you can do custom sizing, so you could punch in the exact number. But in this case, we're going to go with the closest drill size. Our default end condition is through all, but it could be up to the next feature, vertex, surface, or offset from the surface, which would give you a typed in distance value. This icon here allows you to flip the direction, so if you pick the wrong side of the part, you can reverse the direction of the drill. Near side countersink, near side will be default. You can put a really small chamfer on your hole. I'm going to set that at disabled for this hole. It's really small. And you can put chamfers on both sides or countersinks. And then we have our nominal drill diameter and tolerance here. So let's go ahead and bump that up to three positions of tolerance. And we can put our tolerance in as a limit. And we're going to be negative 0.003 or positive 0.002. And that should put our tolerance at the same ratio as the drawing was. Okay, so when we're done with that, we need to select the positions. So there's a handy tool in SolidWorks. We're going to pick the plane that we want our hole to go in, and you'll see this hole moving around. And at this point, you can pick relations. So you can pick the center of the circle, or in this case, we can just select the origin as our place. Now, if you're going to do a bunch of holes, you would need to set up ahead of time a sketch of all the locations if you don't have places to pick to. We can forego that step because our hole is going to go right on origin. It's going to be it's going to be right on origin and concentric to the outside diameter. Now if I wanted to add another hole out here, I could put it there, but I'm going to need to put dimensions to index it, or have a sketch lined up ahead of time where I can pick on the points. Like I said, we're going to accept that hole, and it now creates it for us. Now it defaults by showing you a sketch of how it develops, and that will disappear once you're no longer selecting the feature. Okay. So now we have a hole feature, but if I again wanted to come back and edit this feature and turn that into a counterbore hole, I can very quickly select the counterbore, and it's going to put a standard size counterbore for that size screw in there. Alright, so let's change that back because that's not what we want. And we're pretty much done with this part using that method. It's a few more steps, but it's a quick introduction to the hole wizard, which is a very time-saving feature when you're doing lots of holes. Alright, so if we want to, we're going to go back to our material and edit our material. And our drawing says that this is brass, so we're going to use our same copper alloy for brass material. And it'll apply the properties to that and change the color. Okay, that's it for this tutorial, and you've now finished all of the parts in this series that are similar for the Stirling 60 engine. The next set will ratchet up in complexity, and I look forward to seeing you in those videos. Alright, catch you in the next one.